Today we will be discussing about Pauli's exclusion principle. We know that the Schrodinger wave equation proposed in 1926 have many merits, like it was able to determine the shape of shells and subshells. It was able to tell us about the quantum numbers, which are the address of electrons. But meanwhile, on the other hand, it has some demerits, like it could not tell how the electrons are filled inside these shells. And we know that according to the Schrodinger wave equation, the oneness orbital is having the lower energy. So all the electrons would prefer to be present in the lowest energy level, that is oneness. But we know that this is not the case. One of the principles which guide the filling of electrons in orbital is Pauli's exclusion principle, proposed by Wolfgang Pauli. He was born in 1900 in Vienna, moved to US in 1940 to get away from Nazis. He was awarded Nobel Prize in Physics in 1945 for the Pauli's exclusion principle. Pauli's exclusion principle states that no two electrons can ever be in same quantum state. That is, simply we can say that no two electrons in the same atom can have the same set of all four quantum numbers. For example, let us consider the case of oxygen. We know that oxygen is having an atomic number of 8. The subshell electronic configuration is 1s2, 2s2, 2p4. So, consider the fourth electron entering into the 2p orbital. We have two spins, that is spin up spin and down spin, plus half and minus half. The fourth electron can be having plus half spin or minus half spin, but the fourth electron entering to the 2p orbital will be essentially minus half. This is because of Pauli's exclusion principle. Because if the electron entering the fourth electron is having a spin of plus half, then both the electrons in the 2px orbital will be having the same four sets of quantum numbers, that is n is equal to 2, l is equal to 1, m is equal to minus 1 and ms is equal to plus half for both the electrons. But according to Pauli's exclusion principle, we told that this won't happen. As a result, the two electrons which enter to the same orbital will be having the opposite spin. Also, is there any chance for entering of third electron? No. If a third electron is entering, it should have either plus half or minus half spin. So both the electrons should have the same four quantum numbers. It will not happen. Now let us see more idea about electrons. The quantum particles are two types on the basis of spin, bosons and fermions. The system of particles with integral spin, that is 0, 1, 2, are described by symmetric wave functions. Such particles obey Bose-Einstein statistics and they are called as bosons. Systems of indistinguishable particles with odd half spin are described by anti-symmetric wave function, and such particles obey Fermi-Dirac statistics and they are known as fermions. Electrons are fermions. They are indistinguishable particle. What is indistinguishable particle? They have the same mass, same energy, same charge, right? So if we have two electrons, let us say, to distinguish, let's say it's as A and B. A at the first place and B at the second place, as in first picture, and B at this first place and A in the second space, as in the second picture. Both of them are same. Means there is no difference. They are indistinguishable. We know the wave function. Wave function is the solution for Schrodinger wave equation, and wave function itself does not have any physical significance. We measure psi square. Psi square, that is the probability density, that is probability of finding the electron, is a measurable quantity, and using this we can tell about how much is the probability of finding an electron. For example, in this picture, the probability is 5%. We have psi square equal to 5%, which means that the probability of finding the electron at that point is 5%. So, for electron, we can write, we have the wave function will be same whether we exchange both the electrons, because they are indistinguishable. That is, psi AB square is equal to psi BA square. Taking the square root on both sides, root of psi AB square is equal to root of psi BA square. The solution of this equation will be having two solutions, right? Psi AB is equal to psi BA, or psi AB is equal to minus psi BA. Psi AB is equal to psi BA. That is a case of boson, that is having symmetric wave function. Our area of interest is fermions, where psi AB is equal to minus psi BA, that is antisymmetric wave function. What is antisymmetric wave function? See, in this picture, in the first illustration, we can see that we have two energy levels. Assume that we have two energy levels, 1 and 2. At the first energy level, there is electron A, and the second energy level, we have electron B. In the second case, first energy level, we have electron B, and second energy level, we have electron A. The wave function obtained in the second case is exactly the negative of what it was before, which is exactly what we want. That is what is meant by antisymmetric wave function. So, we can say on the basis of this that according to Pauli's exclusion principle, no two fermions may occupy the same quantum states. Now consider we are having some electrons in atomic energy level. We have a nucleus at the center and electrons. The electrons will be arranged one by one. But we know that this is not quite right? Suppose if all the electrons are not falling, and also all the electrons are not falling in the lowest energy level. The first shall have 2 electrons, the second shall have 8 electrons, like that. Why? In the first shell we know n is equal to 1, L is equal to 0, M is equal to 0. The only quantum number which could differ is the spin quantum number. So, it can accommodate a maximum of 2 electrons. In other words, we can say at least one of the quantum numbers should be different. So Pauli's exclusion principle was able to explain why all of the atoms that we see around have an electronic structure, why each level is only allowed to have certain number of electrons in it, like that. Lastly, let me say that if electrons were bosons, then the electrons will be filled in the same energy level, that is the lowest energy levels. But since the electrons are fermions, the Pauli's exclusion principle allows only the 2 electrons can be accommodated in one orbital. Thank you.